So we've spent 55 minutes, and we have 15 minutes left. I'm only spending half the class on this. So. All right, so I want to spend 15 minutes to discuss some practical text mining techniques. All right. And so here we go. So these are just ideas I had from reading the papers and things that in almost any study you guys would need to think about. So there's this idea of removing stop words. Okay, so let's say you have your text and you want to look at, you want to analyze it and do whatever. Usually you don't look at the common words, the, of, and. So you can remove all the stop words. And there's lists of stop words on the internet, so you can remove them. So there's this idea of stemming and lemmatization. So what that means is you take a word and all of its, they call them, well, I say permutations. There's another word for it. And you change them all basically into the same root word. So the word running, runs, gets cut down. All of them are the word run. Okay. Now lemmatization is a little different than stemming. So stemming uses these rules to basically cut off the end of a word so that all the root words are the same. So you have one root word. Lemmatization would be, it's a little more involved. You can take like the verb to be and all the different conjugations and lemmatize it and transform them all into the word be. You know, the root form of the verb. So are would turn into be, was would turn into be, okay? And also what hasn't been used a lot in the literature and in accounting is something I do a lot of though. So once I publish my studies, it'll be in the literature. It's part of speech tagging. So we haven't really talked about this yet. I did talk about it a little in the last class, so this is a little more detail of what it actually means. So in part of speech tagging, you assign a part of speech to every word in a document. So these are the parts of speech in the Penn Treebank, which is a tagged set of Wall Street Journal articles. They went through and manually tagged them. So you might have adjective as a JJ, noun is NN, verb is VB, then you have things like past tense verb. So I've used part of speech in a few ways. So one way I use part of speech is I look for sentences that begin with a verb. So what kind of sentence would that be? A command, yeah. No, not imperative. Yeah, imperative sentence, right. So I was trying to create a measure for dominance. And I thought if people begin with a verb, then they're giving commands, they're more dominant. Okay, I also created a measure for calculating the passive voice. So the passive voice is like, instead of saying, I hit the wall, say the wall was hit. Okay? So you're basically removing the actor from the sentence. So the wall was hit. How would you detect that? What would that be a combination of? Well, I guess you'd have to see examples here. So I think it is, yeah, that's right. So you can look for whatever was is. I think that's, it's like the verb past participle. Anyway, I need to look at my measure. Yeah, 28. Yeah, and it also has to be the verb to be. There's another way of doing passive voice as well. You can say has been hit. The wall has been hit. So you have to look. Yeah. So in that case, you look for the word has or have. Then been, which, yeah, I think that's the past participle. Anyway, can't remember my exact measure, but I have it really works actually. I can count passive voice. All right. Another thing is maybe you just want to know the ratio of nouns to adjectives. What would that tell you? Yes, descriptive. How descriptive the document is. Flowery, if it's a love poem. That also goes for, what's the other pair? Okay, so there's nouns, adjective. What's the other pair that's similar to that? This is like SAT test. Yeah, verbs and adverbs. So adverbs describe verbs. Adjectives describe nouns. So this descriptive measure, I do the ratio of nouns plus verbs to adjectives plus adverbs. Yeah. Okay. There's other ones other things you can do too. You can just do raw count of verbs. How active is the speech, things like that. Okay. All right. So part of speech tagging is not hard to do if you just with like 5 lines of code and the right libraries on my computer, I can tag a sentence. Do the part of speech tagging. Okay. So what I believe is text mining begins with pattern matching. Even in all the cases, we've been looking at a lot of pattern matching. So if you look at these dictionaries of words, they're lists of words, right? But you have to match the words in the documents. You're counting the words in the documents. That's a pattern. Each word is a pattern, and you're matching its existence in a document. So I'm generalizing here. So pattern matching includes using dictionaries. You're counting how many times this pattern of letters occurs in a document. There's other patterns you can discover too in documents besides single words. Maybe you're interested in email addresses. So maybe you want to look for words and numbers, followed by an @ sign, followed by letters and numbers again, followed by a dot, followed by a 2 to 4 letter thing, like .com, .info, .edu. So there's all different kinds of patterns you can find in text, and once you find a pattern, what can you do? You can count it and measure how many times it appears in a document or in a corpus. So pattern matching is very old. It's almost as old as computing. And there's this mechanism for matching called regular expressions. So you know about this, right? Well, all right. Well, you will. So regular expressions, if you can master regular expressions, then you can do lots of things. You can match patterns. You can parse documents. For example, maybe in my case, I want to take all the mDNAs out of the 10K. So I look for all the matching patterns where it says item 7, management, discussion, and analysis section. And then I say, give me everything after that, and give me everything before item 8. So I'm matching these patterns and extracting whatever's in between them. Okay, so you use regular expressions to do that as well. So it's not just finding and counting things, it's also parsing documents. Yeah, so these look behind and look ahead functions in regular expressions are things like I was saying, look ahead for item 8, give me everything before it, or look behind for item 7 and give me everything after it. Okay, can you guys read this? Okay, so here's a regular expression. The letter A. And what does it match? Right. Okay, Denise, you're on fire. Okay, and AB matches AB. And KEVIN would match KEVIN. Okay? Okay, it gets a little more complicated. All right, my name's Kevin. So a star is a special character. So A is still the regular expression, okay? And it's basically modified by a star. And it matches, star means 0 to infinity. So A matches nothing, or it matches 1A, or any number of A's. A star does. Because A is the regular expression, which matches, right? But star means 0 to infinity of A. So there's 0 A's, so it matches. There's 1A, it's still... I mean, there's no power. This is not a exponent, okay? All right. It's just saying the star modifies the regular expression before it, okay? Which means it repeats 0 to... Understand? This is called regular expressions. It's right at the top. Works in English, works in any language. It works in whatever text you're looking at. I know. That's like Microsoft, hokey user-friendly language. This is real stuff. So when I created a programming language, it wasn't really a good one. I built regular expressions to give all the valid terms in that language. So like, anyway, you'll understand maybe a little more. But yeah, regular expressions are hardcore, but they're easy too. Okay. So plus is different than a star. So plus matches, plus says there has to be one, at least one A, but there could be infinite also. So it matches these A's, but not an empty string. So parentheses are grouping signs, okay? So AB is the regular expression modified by a star. So it still matches nothing, or matches AB, or AB, 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 but not ABA. It has to be the A and the B. Okay, so here's another special character. The dot, the period, matches basically anything. By the way, regular expressions are case sensitive. So one period would match 1A, 1 4, 1 pound sign, 1 percentage sign, 1 capital A, or 1 capital B. So it's just a wild card. It's your star. Now it's a period. Yeah. Yeah. That's all false now. Get it out of your head. Okay. So here's another special character. So a /W matches 1A, 1B, matches any letter or any number. So A, B, Z, 1, or 9. /W. Okay, so here's an example. So /W matches any number or letter. Then the plus, what does that mean? It means there has to be at least one /W, or there could be infinite. Okay. So /W plus, then there has to be an @ then another /W plus, then a .com. So this would match kmoff at email.com, because /W plus would match all these characters. Then there's an @ because @ doesn't match in /W, right? Because it doesn't match special, only numbers and letters. So it looks for the next thing is an @ and it matches here. Then another /W plus, which matches email. Then a /period, okay? So if you want to actually match a period and not have the dot be a special everything character, then you escape it. You put a slash in front of it. So a /period matches the period, and then a com matches com. So I can find all the email addresses that follow this pattern. It's not, maybe there are better patterns, right? Like sometimes there's a .com.uk or something. Okay, so this is a phone number. Right. So slash parenthesis means match a parenthesis. Okay? It's not grouping things together this time. It's saying actually match a parenthesis. A question mark means that parenthesis can be there 0 or 1 time. Okay, so it doesn't have to be there. Slash D means match a number. Not a letter, or any, just a number. And this 3 in curly braces means there has to be 3 numbers. 3 slash Ds. Okay? And I put that in parentheses. I don't even know if I need those parentheses. Then here's a slash parenthesis again. See, this is the area code. So, and actually, did I do that right? Anyway, so I'm basically saying this whole thing's. So what I need another parenthesis to say this whole thing, and another question mark to say the whole thing is optional. But anyway, here's a dash, question mark, which means the dash is optional. Okay, so here's the 3 digits that have to be there, and a dash that has to be there, and 4 digits that have to be there. Okay. So here's a Visa credit card number, and American Express. Okay? Right. I'm not done. I need 5 more minutes on this. I know. All right. I just need to tell you a couple more. So any like text miner, text analyst, or whatever you call us, anyone worth their salt knows how to use these, right? So another special character is, okay, this square brackets means or. So this would match a B or C, okay? So a B or a C. Here's another or. This will match ABC or XYZ. Okay? ABC, XYZ. Okay, now an exclamation mark means nothing. It's just an exclamation mark. Okay. So a caret, and then another symbol, like a comma, for example. This means anything but a comma. Okay? So this does not match. This is not equal to a comma. That's not equal. Yeah. And then, let me see, I might have one more to show you guys. So remember, spaces are also matched. Spaces are characters too. Yeah, that should be it. Oh, here's another thing. This is every letter, every lowercase letter. This matches any lowercase letter. Just once. If you want it to match multiple times, you put like a plus or something. You know. So this is any lowercase letter. A, yeah, because it's A to Z. C, and so on. Okay. So I know you guys want a break, and I'm going to give you something to take home and work on. So I have this worksheet for you, so you can practice your regular expressions. Now, there's usually, I think, more than one right answer. So you have to find, all right, there's 1 through 6 and 7 through 9 on 2 different pages. So you start. So you can take these and then take your break. Or you can work. So when I was a PhD student, and what I expect of you guys is to create an online application for processing text. Okay? So Splice is a linguistic analysis tool. What does it measure? I don't even know anymore, because I know my buddy has been changing some of it. So basically what I wanted, when I was a PhD student, I was stuck with this tool that I hated. I didn't know how to use it, and it was so horrible. Thank you. Yes. So I started learning Python, and I started programming. Then I thought, well, I had a tool when I got here I didn't like. Well, now I'll leave the lab with a tool that works much better than that tool did. So I created this program, and it counts things like number of characters, number of sentences. So what you do is you upload text documents, then you select which cues you want, and then it outputs a CSV file with the name of the text document down the left, and then the cues across the top, and the counts for each text document. So it doesn't handle large documents very well, or large documents or large quantities of documents. Yeah, well, I'm older than you. All right, so parts of speech. So that uses my part of speech tagger. Immediacy has my passive verb, passive voice stuff. All right. Pronouns, that's part of speech tagging as well. So I created these positive self-evaluation, negative self-evaluation measures. Influence, I have this dominance measure I was telling you about. Submissiveness, deference. So that was what one of my advisors, I had co-advisors. One was in communications, and she was really into this dominance, submissiveness dynamic in communication. And so she wanted me to try and create measures. They've never been validated, so I wouldn't recommend using them. Okay, so complexity, so things like average word length. Some other things like expressivity, disfluencies, tense, senti-wordnet, and readability. So senti-wordnet is this, what I was aspiring to. It relies on, it kind of does this word sense disambiguation. It doesn't quite work. So it's supposed to calculate the positivity and negativity and objectivity of any word, and depending on how that word is used. Okay, and it doesn't work because I was trying to get the Perl module to work, and anyway. So what's cool about this is you can access it as a kind of like an online service. So you can manually upload files, or you can call the online service in your code, and here's some sample code. So you can just write a few lines of code here, and get the values sent to you like in XML format, and you could integrate it with your website or something like that. So that was the idea there. All right. What else? Well, I won't